Okay, this is the video for the rest of the Unit 5C review packet. All right, so number 27, given the function, written in intercept form, find the following. Okay, so when it's an intercept form, it gives you the x-intercepts right off the bat. So if you actually want to solve them, which is what you need to do for x-intercepts, you'd set each of the factors equal to 0. I don't have to worry about the -2 because there's no x with him. So x minus 1 has to equal 0, and x minus 5 has to equal 0. And then you're going to solve both of those equations. So add 1. So x is going to equal 1. For the other one, you're adding 5 to both sides. So x is going to equal 5. Okay, those are your two x-intercepts. And remember, you might also see it as a point. So this would be 1, 0, and this would be 5, 0. Okay, what's the axis of symmetry? So when you're given it in intercept form, you don't have to FOIL it back out. You can if you want to, and then use x equals negative b over 2a. But I give you the two x's, and the axis of symmetry is right in between them. So you're finding the average of the two. So you have to use the solutions, though, to find the axis of symmetry. So you're going to do 1 plus 5 divided by 2, x equals, which is 6 over 2, which is 3. So your axis of symmetry is x equals 3. Okay, and the vertex has the same x as the axis of symmetry, because remember, it goes straight through the equation. So this picture would kind of look like that. And you have your axis of symmetry, and then your vertex is the same x. Okay, so I already have the x of the vertex. I just need to find the y. So I'm going to plug this into the original equation. So f of 3, remember it was f of x, but I have the x, -2 parenthesis 3 minus 1, 3 minus 5. So that'd be -2 times 2 times -2, 2, 4, 8. Negative and negative is positive, so positive 8. Okay, if you're unsure, use your calculator and just type it in. So turn it on. -2 parenthesis 3 minus 1 parenthesis 3 minus 5 gives me an 8. Oh, y'all can't see that. There you go. So I just typed in the original. Okay, let's see. The next one says, given this function, again in intercept form, you're doing the same thing. Okay, if you didn't know how to do 27 and 28, pause the video because now you have an example. You have 27 down, so pause this video and do 28. When you finish 28, then resume the video. Okay, hopefully you've tried 28. So again, the x-intercepts, x is going to equal -2 and -8. Or you could see it written as a point. Okay, so either one is fine. I'm just going to bubble out. Okay, axis of symmetry, you're taking the 2 and you're adding them together and dividing by 2. So that's a -10 over 2, which is a -5. And if you think about it, this should make sense. So x equals -5 is your axis of symmetry. If you think about it on a graph, so 1, 2, 3, 4, 5, 6, 7, 8. You're at -2 and you're at -8, and I need directly in between it. So 1, 2, 3 hops over, 1, 2, 3 hops over is the middle because there's 6 spaces in between. So 1, 2, 3, 4, 5. So that in fact is -5. So if you're unsure, sketch a little graph or use graph paper. Okay, so if this is my x, that's the same x as the vertex. Okay, I just need to find the y now. So again, plug it into the original. So f of -5 is going to equal -5 plus 2, -5 plus 8. Let's see, that's -3. Yeah, -3 and 3, so that should equal -9. Let's just check my math. Also, you can also type this into the table. So if you're using the table, delete what's in there, it would be x plus 2, x plus 8, enter, 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 enter. I need -5, and -5 tells me it's -9. Okay, next page. Okay, 29. Given the graph to the right, find the following interval of increase, decrease, and end behavior. So end behavior, you're literally just looking at the end. So remember, these actually have arrows. They're not drawn, but you always have arrows. And your end behavior literally just looks at the ends. So both of these arrows, they have to either be facing down or up. Both of these are facing down, right? It's a frowny face. If you put little eyes on him, he's a frowny face. Okay, so these are both negative infinity. That's really bad, negative infinity. Let's try that again. There we go. Okay, an interval of increase and decrease is based off of your axis of symmetry. Okay, so my axis of symmetry is x equals 2. Okay, that's going to matter. So if I break this in 2 halves, right, I have a left half and I have a right half. This left side is increasing, and this right side is decreasing. So since the left side is increasing, your left side starts on the negative side, okay? Your left side will always start on the negative side. So I'm going to label that as negative infinity. The right side will end at infinity because it's on the positive side. So when you're doing interval of increase and decrease, it's based off of the infinities you wrote, negative and positive infinity, and your axis of symmetry. So it's increasing first. So negative infinity to 2. And then from 2, it's starting to decrease. So 2 to infinity. If you label it this way with your axis of symmetry, increase, decrease, your negative infinity, and then your positive infinity, that's all you need for interval increase, decrease. So make sure you're labeling your graphs. Okay, the standard form for a quadratic equation is ax squared plus bx plus c. Okay, that's what you had to put into that equation. The parabola will open up when the a value is what? Positive. In this case, the end behavior will be, well, if it's positive, it's opening up. It looks like this. So they're both going to be infinity. Okay. The parabola will open down when the a value is negative. Okay. If it's facing down, opening down, that means these are both negative infinity, just like this one we had above. Okay, so then here you had to label, this is opening down, which means your A is less than 0. That's what makes it negative. This one's opening up, so your A would be greater than 0. Okay, let's go down below. Make it straight for you. Okay, so number 31, it says factor, and then we'll use a table and then answer these questions. So let's just factor it first. So if I factor it, I have to multiply to -8, but add to 2. So let's see, 1 and 8, 2 and 4. Only these will make a 2 out of them. So when I factor it, sorry if you hear chirping in the background, guys. My cat is playing with his toy and it makes a chirping noise. So when I factor this, one of them has to be negative and the smaller one has to be negative because 4 minus 2 gives me a positive. So if this is positive, the bigger number has to be positive. If this was negative, the bigger number would have to be negative. Okay, so it's all based off the bigger number. So this would be x minus 2, x plus 4. Okay, so that's factored. And then right off the bat, I can figure out what my x-intercepts are going to be, because I solve it. So my x-intercepts, if I solve it, I'll show the work for it. Okay, solve means set equal to 0. Add 2. X is going to equal 2 minus 4. X is going to equal negative 4. Okay, so I'm going to write it as a point, just so you can see it as a point, so you can keep practicing it. Okay, but you can write it either way, x equals or as a point. Okay, what else do I know right off the bat? Let's just graph it. Okay, so I'm going to go ahead and plot my x-intercepts on my graph. So 2 and 1, 2, 3, 4, negative 4. Okay, so since I have this, I could figure out where my axis symmetry is just by counting. So there's 1, 2, 3, 4, 5, 6 hops. So that means half a 6 would be 3 hops. So 1, 2, 3. So my axis of symmetry should be going through negative 1. I could also use my original equation, which is what I'm going to do so I can show it to you again. I'm going to use the x equals negative b over 2a. Okay, so x equals negative b over 2a. X is going to equal negative 2 over 2 times 1. X is going to equal negative 2 over 2, which means x equals negative 1. Okay, and I figured that out already. So let's go ahead and draw that in. Remember, it's always a dashed line. So where is that on here? Axis of symmetry. X equals negative 1. If I know this, I also know part of the vertex. It's going to be negative 1 comma something. So let's plug that in. Let's use the table. So if I plug in negative 1, and I'm just going to show the table so we can use it later. It is, let's see, x squared plus 2x minus 8. Start at 0. Okay, I need to go to negative 1, so negative 1 is negative 9. Okay, so this right here is my vertex, which means this needs to be the middle. So let's choose a couple points smaller and a couple points bigger. So negative 2 is negative 8. Negative 3 is negative 5. And look, negative 4 is 0. We already knew that one. Check. We knew that already. Okay, let's go the other way. 0 is negative 8. And remember, it should repeat itself. So that means 1 is negative 5. And 2 should be 0. Yep, because we already knew that. That's also an x-intercept. Okay. And we already answered this question of y-intercept because this right here is the y-intercept. 0, negative 8. All right, let's plot these points. Negative 4, 0, we have that. Negative 3 is 1, 2, 3, 4, 5. Negative 2, 5, 6, 7, 8. Negative 1 is 9. So negative 1 is 9. Let's just go ahead and fill that in down here. 0 is negative 8. 1 is 1, 2, 3, 4, 5. And we have the next one. So let's go ahead and connect our dots. This is a pretty nice U shape. Okay, make sure when you're drawing it, you always have arrows. Let's see what else we know. Is this going to be a max or a min? It's a valley, right? It's not a mountain. It's not going up and down, right? Let's go back up here. This right here is a max. It's a hill. It's a mountain. This right here is a valley, so it's a minimum. Okay, so let's go back. So this right here, my vertex, is going to be a minimum. My domain is always what? You should be telling yourself negative infinity to infinity. That's my domain always. My range is bottom to top. If you don't remember,